Hello everyone, welcome back here. So today we're gonna introduce another technique to evaluate the limit, which is 2.6, the limit at infinity. 2.6 at infinity limit. So as in previous sections in 2.2 and 2.3 and 2.5, and we learned how to solve like a limit at a specific value. And for 2.5, we learned the limit of two-sided and whether the function it is continuous or not. So in previous sections, we learned how to compute the limit at a specific value. And now we're going to study long-term behavior, or it's like a horizontal asymptote. Horizontal asymptote. That as x goes arbitrary, as actually arbitrary large, that what is behavior of a function output? Long-term behavior is horizontal asymptote, and we define it as x approaches to infinity of a function f of x is equal to like the limit. So the limit of f of x will the limit of f of x as x goes arbitrarily large, a larger positive values. The output it is as near as the L. L. So for example, here, let's do like a visual here. You can see as the f of s goes arbitrarily large, the value as near as 5. So like we can say that the limit of f of x as x approaches infinity of f of x is 5. It's horizontal asymptote. And you can see it is a horizontal asymptote. And in the same way, if we have this definition, it's like a limit x approaches a negative infinity of f of x, it is L, but this just means like the limit of f of x as x goes a smaller part, a smaller negative value. So we're going to arbitrarily small or arbitrarily negative. It's also this identical thing as this. So the output of the function gets near as L. Page number get closer to L. Another example here, if we here's g of x perhaps, and the limit x goes to arbitrarily large, or it's like perhaps this is like a 0, this is like a -10. Sorry, I just reversed the axis. It's a reverse x-axis. So as x approach like a larger negative value, so we have is this negative infinity of g of x, it is a -5. Now I'm going to introduce 9 very important laws for limit as this chapter, this part of the limit. Introduce the 9 important limit laws. And for number 1, as the limit of x approaches infinity, x to the power -nth, or it's like 1 over x to the nth is like a, and we write the negative half because x to the 0 is 1. Of 1 over x to the nth, it is a 0. Make sure n is larger than 1. Number 2, have it's like x to the nth, but it's a negative infinity. Equal to x n. Equal to like the limit of x to the nth is 1. For number 3, it is like the natural log of x. To infinity of like ln x. It is positive infinity. Number 4, it is e of x. E of x, it is infinity. And number 5, it is e of x, but it's negative infinity. And number 6, it is like the infinity, but it's e to the negative x power. A 0. Number 7, limit x approaches negative infinity. Beta e to the negative of x power, it is infinity. And number 8, it is arctan inverse tangent. Is pi over 2. And number 9, you have is not the inverse tangent, but it's negative infinity. It is a negative pi over 2. Now we have 9 most important laws for limit for section 2.6. Now let's try an example here. Evaluate the limit. We have the x limit x approaches infinity of 9x to the 4th minus 7x to the square and plus 21x. Have it as 15x to the 4th plus 20x into the square minus 42x to the cubic. Now, what's your observation? The highest power is a 4, right? Both the denominator and numerator have a highest power of 4. Then we multiply by 1 over x to the 4th. The highest power of 4. Then we just like multiply all terms. All terms. Make sure to multiply by all terms. Let's do this step. Fifteen x to the fourth. And multiply by, and we can write as x to the negative fourth. Note that and then we just multiply the term and then just write it out. It's 9x to the 0, so it's 9 minus 7x to the negative 2. And plus 21 x to the negative 3. And then there's 15. Okay, plus 20 x to the negative 2. And then minus 42 x to the negative 1. And then apply the limit law. Then what we have, it's like a limit x approaches infinity of 9 minus 0 plus 0 over is like 15 plus 0 minus 0. So the final answer is 9 over 15, and which is 3 over 5. Here's the strategies for this type of the limit. If you see both the numerator and denominator have the same power, has the same power, then we just multiply them by 1 over the highest power. Same highest power. Then we divide all terms by the highest power. The answer is the quotient of the coefficient of the highest power of the term with highest power. In this case, if we see that the highest power is 4, then we just divide it by the power of 4, or we can multiply -4. We cancel it out, we rewrite the limit, and then apply limit law. Try another example here. Evaluate the limit. So this time, I will have a limit x approaches infinity, 12x to the cubic minus 40x to the 5, and minus 24x to the 4th over, you have 28 x to the 5th plus 4 x to the 4x to the squared minus 14x to the x to the cubic. Now pause the video. Maybe try down around to solve the limit. See if you can do it. I trust you. Perhaps it is on the homework or the exam. The highest power rate is 5. Then we divide it by x to the power of 5 and just evaluate the limit. (28) to the 5 minus 14 the cubic, and we multiply by the highest power, and it's going to be x to the negative 5. We rewrite the limit as the limit x approaches infinity of 12x to the negative 2 power minus 40, and the plus is 24 x to the negative 1. You have it at 28, and the plus of 4 times x to the negative 3, and it'd be minus 14 x to the negative 2 is a 0, 0, 0, and a 0. It's like a 0 minus 40, then minus. Be careful of those mistakes. I apologize for it. A 0 over 28 plus a 0 minus a 0. So we get it is a negative 40 over 28 or negative 10 over 7 is our final answer. Now, do you want to try another example here? Example number 3. Evaluate the limit. and minus 20x minus 16x to the cubic over 26x to the 8th plus 45x to the 7th, the minus 9x to the 9th. What is your observation? The highest power rate is 9, right? 9 is the highest power. And it's at the denominator, and we cannot have a denominator that is undefined because the denominator cannot be a 0. And it's a denominator. Then we divide all term by the highest power in the denominator. Or the highest power in the denominator. Because denominator cannot be a 0. Cannot be a 0. Then divide power up 9, not a 6, not 8. Now just let's roll. (26) to the 8th plus 45 x to the 7th, the minus 9x to the 9th. We multiply them by x in the negative 9th. Seventh, I forgot this. Okay, and then just rewrite a limit of infinity, and what we have it is 36 to the x to the negative 3 minus 20 x to the negative 2 minus 16 to the x to the negative 6. We have 26 to the x to the negative 1. We have 45 over x to the negative 2. And we have a negative 9. It's like a limit x approaches infinity of like a 0, 0, 0, a 0, 0, 9. So it's like a 0 minus a 0 minus a 0 over a 0 plus a 0 and minus a 9. It is a 0 over negative 9, so it's a 0. So in this case, the highest power, it is on the bottom of the function. So we divide the highest power on the bottom of function. Exists on the denominator. Then we divide all terms by the highest power on the denominator. Since the denominator cannot be a 0, the final answer is a 0. Do you want to try another example here? Example. Evaluate a limit. We have it's like limit x approaches infinity of 4x to the 7th minus 7x to the 4th, and we plus 14x to the 5 over 12x to the 10th and plus 21x to the 8th minus 25x to the cubic. Maybe pause the video, try down it on, perhaps it is on the actual exam. Now let's begin. Highest power is a 10, so divide by 10. In this case, we can divide it by 7 because if you divide 7, this is all gonna be a 0, so can't. by negative 10 is the power. What we have it is like a limit of 4 to the negative 3 minus 7 to the negative 6. And we plus the 14 x to the negative 5. Have is 12 plus 21 x to the negative 2 minus a 25 x to the negative 7. Then we have its up, then we apply limit law, it is x limit 0, 0, and a 0. 0 minus a 0 and then plus a 0. 12 plus a 0 minus a 0, so it is a 0. It's a limit. Let's try our last example here. Last example here. We lost 2 examples here. Evaluate the limit. Through the x to the 4th. And minus 52 x power to the 13. What you have on the bottom is 45 x to the 14th. X to the 9th. Plus 64 x to the 6th minus 25 x to the 25x squared. The highest power to 13, but it's a numerator. So we divide the highest power in the denominator because we do not want the top, we do not want the bottom to be a 0. But we do not want like a letter to be a let the denominator should be a 0. So we divide it by 9. The highest power in the denominator. What we have it is the limit is equal to -9 what we have is plus 64, actually the 6, and minus 25 x squared. And what we have is a limit x approaches infinity of 27x to the negative 1 minus 30x to the negative 5 minus 52 x to the 4th. What we have is like 45 plus 64 x to the negative 3 minus 25x to the minus 7 of the power. Then we apply the limit law. Zero minus minus infinity over 45 plus 0 minus 0. So it is a negative infinity. So when the power, if the highest power is on the numerator, we divide all terms by the highest power of the denominator. And then cancel a polynomial null. The answer will be either it is negative infinity or positive infinity. Now let's do the last kind of a hard example. So if you encounter a limit involving radicals, how are you gonna evaluate, right? So I would do this example for you. The limit x approaches infinity of x squared plus 1 is a radical and then minus x. If you see radicals, conjugate the radicals. Conjugate the radical. It's going to be This should be x, not infinity. Multiply by this term. Then we just rewrite a limit. It is x squared plus 1 minus x squared over radical of x squared plus 1 and a plus x. Then we simplify the limit. One over so plus 1 and a plus x. It's larger. And for this, it's like this denominator of this last expression as x becomes larger as x approaches infinity than x, so it is a 0. Goes infinite large as x approaches infinity. Okay, that's all for section 2.6, which is the limit, last limit evaluating strategies. But next we're going to be 2.7, which is the limit definition of the derivative. Thank you guys for watching. Have a good day. Yes, have a good day.